my name is Katie O'Neill and I am the marketing manager here at the UCD College of Engineering and Architecture. So you're very welcome today. This webinar will give an overview of the number of top graduate masters available in the School of Mechanical and Materials Engineering here at UCD. I'm very lucky to be joined by two of our academics who will speak to you, and also two very recent graduates, both from this year and 2019, who will also give their experience. So without further ado, I'm going to hand you over to Professor David Timoney for his presentation. Thank you.
Thanks very much, Katie, for the introduction. So just to quickly give you an overview, we have four speakers today, two academics, two graduates of the relevant programs. So I'm going to give you a quick introduction to the Energy Systems program and the Mechanical Engineering program, and Dr. Mert Celikin will give you an overview of the Material Science and Engineering programs. We'll do that first, and then we'll have lots of time for input from the recent graduates and time for questions and answers. So the Masters in Energy Systems Engineering. This program has been running for about 10 years. It's not very surprising that we're running a program on this topic. I mean, first of all, I'll point out quickly that there's a very strong relationship between energy use and money, or GDP, and a lot of our wealth depends on exploiting energy resources. And of course, there are difficulties with this. I mean, if you look at the history of the last 25 years, you know, we're using lots of oil and natural gas and coal and some nuclear energy and some hydroelectricity. And the growth in the total over the last 25 years has been enormous at 67%. And of course, the fraction of renewable energy that we're using at the moment is really quite tiny. If you include hydroelectric and renewables, it's still only 11%. So a big consequence of this is, of course, that the carbon dioxide concentration in the atmosphere is rising dramatically. I mean, again, over the last 20 years, from May to May, it's 12% up, from 371 to 417 parts per million, a huge issue for the planet, as you will, I'm sure, be aware. So the master's program aims to prepare graduates to meet the engineering, economic and environmental challenges facing the energy systems of the future. It deals with electricity systems, buildings, food system, industrial production, transport system, and of course, the climate impact and CO2 emissions are in the background at all times. So the entry to the program is normally built on 3 or 4 years of foundation studies, usually in mechanical engineering or electrical/electronic engineering, but other disciplines are also appropriate. Just the prior learning differs slightly depending on the pathway. So just very quickly, the program deals with traditional fossil fuels because that's what we're moving from. It deals with lots of renewable energies, from electric vehicles to energy storage to wind farms to solar farms, etc. Some of them in more detail than others. And also, you know, there's an input from the chemical engineering and agricultural processes that all contribute to this highly interdisciplinary area. So, and of course, wind energy is a huge feature, and of course, the technologies associated with wind energy are partly civil, partly electrical, excuse me, partly mechanical, etc. So I'm going through these things very swiftly because we don't need to discuss them in detail, but the modules that are available then, excuse me, are, you know, relate to anything from overviews on energy systems and climate change to classical engineering thermodynamics, fossil fuels, chemical processes of sustainable renewable energy, energy systems in buildings, some electrical engineering topics like power system operation and renewable energy systems, which deals with the electrical side of wind and solar. There's research skills module, a research project, professional engineering topics like management and so on. And then quite a suite of option modules of all kinds drawn from across the different universities, including modules in entrepreneurship, energy, economics and policy, technical communication, environmental engineering, etc. And nuclear physics, not to be forgotten as an agenda. So quite a suite of modules in the electrical side are also accessible in this program. So moving on to the sort of employers that host our internship students. Essentially, in a 2-year program, the second half of year 1 is spent in industry. That's starting from January and running through to the end of the summer, through the end of August, 6 to 8 months normally. And we have a long list of employers in the energy arena who, you'll recognize some of the names here, who host interns and also who employ graduates later. So they're ranging across a lot of these are mostly Irish industries, but we do have some international groups as well. Some people go into management consulting like Accenture and so on. And we have, companies like Glen Dimplex, Veolia, PM Group, Irish Cement, and so on. A very broad range of employers that students end up either on placement or in after their program is complete. So moving on very swiftly then to the Masters in Mechanical Engineering, the program director is my colleague, Dr. Malachy O'Rourke. This program, it really focuses on in-depth, deeper, higher level study, advanced study of mechanical engineering topics, focusing on areas such as continuum mechanics, solid mechanics, fluid dynamics. Research skills are key to all of the master's programs. Every student completes in the final year a major research project, working with academics and other researchers on a high level project. And of course, the development of professional experience and professional engineering practice during the work placement or internship is a crucial part of all of our master's programs, the professionally accredited ME programs. So the program structure, for example, for the main mechanical masters involves 6 taught modules of 5 credit each in trimester 1. The 30 credit work placement is trimester 2 plus the summer. We do have an alternative for candidates who don't have all the required prior learning to do a shorter 10 credit work placement during a summer perhaps and take 4 additional modules. It's a backup strategy we have in case internship issues arise because of recession or whatever. And then in year 2, we have a major research project, which including research skills modules amounts to about 30 credits. And another 6 taught modules at an advanced level in mechanical engineering specialized topics. So the actual modules are listed here. We won't dwell on them in detail, but you'll recognize them as traditional mechanical engineering subjects involving continuum mechanics, thermodynamics, fracture mechanics, and manufacturing engineering, mechanics of fluids and solids. So there would be a typical mix of modules in trimester 1 of year 1. As I mentioned, the placement is in the second trimester. And then in year 2, there's an additional list of modules shared across the 2 trimesters and a major research project and some option modules. So it's the energy systems program is quite broad and very interdisciplinary. The mechanical engineering program is more focused on in-depth, high-level our focus on mechanical engineering topics. Of course, along with all the master's programs, they are fully accredited at master's level by Engineers Ireland. And so there are a number of professional engineering modules, for example, professional engineering management there that are necessary to cover all the required program outcomes. So again, a detailed list of the core modules and the option modules in mechanical engineering program. A little bit beyond the scope of today to worry about all of them, but just to give you an indication. Moving on then to the internship hosts and employers. Again, a broad range of companies based in Ireland and USA and in the UK and even China have been hosting students on internship and employing them afterwards. Okay. So that's a very quick spin through the mechanical engineering program. And I now hand over to my colleague, Mert Celikin, and I'll have to drive the slides for him, I think, as we look through. So I'll just give me a small hint about each slide, Mert, and I'll move on from one to the other.
Okay, I'll just say we can continue, something like that, to continue. So good afternoon, everybody. Thanks, David, for introducing the other fields. And My name is Marcela Khan, and I'm Program Director for the AMIA Materials Science and Engineering. And today I'm just going to give you a brief overview of the program itself, but less technical details, more about what is the field about, and of course, a little bit of technical details, but then most importantly, what most of you will be asking about, what sorts of opportunities lies for the AMIA Materials graduate. So we can continue, yeah. So basically it is one of the options, material science and engineering is one of the options, just like mechanical, biomedical, and so on. So this field is a very important field in the world, but to start with, what is material science and engineering? Of course, the materials is a very broad term, describes many different objects, from the bicycles to buildings, toys to space shuttles. So the specific field is about the solid state materials in engineering. And the main issue is that every engineering product is a combination of design and construction. So for construction, we need the workmanship and we need the choice of materials. How do we choose those materials? Based on their properties. To enhance the properties, we have two options. Even first, we need to understand the structure, so structural modification by changing the chemistry of the materials or by changing the processing. So that's why material science and engineering focus on understanding the structure and property relationship. So as a field, you can work as a process engineers, design engineers, research engineers. So all options are available for the ME Material Science Engineering degree. Yeah. So to give a brief technical information about the program, it's a 2-year full program, 120 credits. We have dual accreditation, both from the Engineers Ireland Irish bodies and also UK bodies, IOM3, Institute of Materials, Minerals and Mining. So that gives you opportunities that it's a recognized program in the world. So there's only such course in the country, and this allows you to option. This also gives you an option to have a different focus group. So we can continue there. Yeah. You will be taught about the fundamentals and applications of the 4 main material types: metals, ceramics, polymers, and composites, and specific materials like semiconductors, as well as materials processing. But main difference with the other programs is that you can have a focus group of 4 main fields. If you want to focus on the nanotechnology, you can focus on energy, biomedical, or manufacturing. So to have these options, you will have option modules that you can select so that you can increase your focusing point more. And like the other ME programs, this program involves a 6 months industrial work placement. So we can skip the next one. So there are, of course, core modules and option modules. I'm not going to get detailed, but basically they are being separated by the 4 main material types. You will definitely be told, but also with the option modules, you have options to focus on 4 different fields that I already talked about. Yeah. So one of the other questions is, where are current interns working at? So they are working currently at they are doing their internship currently at the aerospace field, biomedical field, energy field, and these are the companies that are involved with these internships. But when you finish, our current graduates, where more than 85% of our graduates are currently employed or pursuing the further education. They work in the aerospace, energy, biomedical, and like a semi-electronics fields. But the materials field is very broad and very interdisciplinary in its nature. So if you want to go outside Ireland, there are also opportunities to work in the automotive sector And so you can broaden your field. So with the core knowledge that we built in this program, you have option to go other places, and you can work very easily in the other fields as well. And with this, I'd like to thanks for your attention, and hope to see you guys on the campus.
So I think that was a very rapid run through, perhaps too fast, but we didn't want to delay too much on the detailed content of the programs rather than give you a strong overview. And of course, hearing from people who've recently been through the experience of studying those modules and getting a job at the end of it, or doing their internship during it, I think we would be very keen to get it from that perspective. So will we hand over to Katherine? Is it Katherine first to just say a few words, and hopefully we'll have some questions and answers to engage afterwards?
Yeah, that sounds great. Okay, thanks David, and thanks Katie for inviting me back. So hi everyone, my name is Katherine Madigan, and I graduated just this past year. So I submitted my thesis, did all my exams in April, May, and basically graduated and started work in September. So as a bit of background, I did my mechanical engineering undergrad in UCD also, and then I stayed on to do the mechanical engineering masters. So over the 5 years that I was in UCD, I got a lot of really good opportunities between kind of scholarships, studying abroad, and industrial placement. So I really had a great 5 years at UCD. So I suppose I primarily chose the mechanical masters because it caters to kind of a broad range of industries. So I'm right now working in biomedical, but I suppose my friends who've also graduated from mechanical are working across aerospace, automotive, biomedical, and then also in management consulting fields. And to be honest, I know probably employment prospects will be something that you'll all be thinking about, especially right now during pandemic times. But all of my friends are currently working, and no one has been let go or anything like that due to COVID, just as something that probably will be maybe worrying you a little bit. So I studied, I suppose, a lot of very technical modules as part of the mechanical engineering masters that David would have alluded to. So, you know, fraction mechanics, continuum mechanics, other things like that. So some would be pretty maths heavy and quite detailed, but very enjoyable. But then I also had quite an interest in material science. So I took a couple of option modules in biomaterials, other subjects like that, and enjoyed kind of professional engineering and technical communications, which is essentially a public speaking module. So there is a bit of scope for taking modules that are interesting to you. I suppose that one of the best things about the Masters for me was the industrial placement. So I spent 8 months in Stryker in County Cork, and Stryker are a biomedical company that specialise in 3D printing, or that's where I was working anyway. So I spent 8 months down there, absolutely loved it, got a really, really good exposure, and enjoyed it so much that I brought my thesis back with me from Stryker. So I did my thesis into electron beam melting, which is a type of 3D printing for biomed, and I did it between Stryker and UCD, which was brilliant. So would really encourage anyone to consider an industrial thesis. I think you get a lot of support and a lot of, you know, extra resources from a big company. So I would definitely recommend that. So I went back in 5th year, continued studying my modules, did my thesis, and just had a really good year. I basically finished up in May, went away for 3 months, forgot about engineering altogether for the summer, and then started back in Stryker in September, and I'm loving it. So I'm working in a kind of an R&D capacity at the moment as a process engineer in their AMIA Institute, which is essentially their Centre of Excellence for 3D printing. So working on new 3D printing technologies for biomedical applications, and really enjoying it. So yeah, as I said, I really enjoyed the Masters. All of my friends have been lucky enough to find jobs that they like and that they're enjoying, and would definitely recommend it. So if you have any questions, obviously feel free to ask at the end, but I might leave it to Duncan there. Okay, thanks.
Very good. Thank you very much indeed, Katherine. A very efficient summary of a great set of experiences. Duncan Matthews has just very recently completed the Masters in Energy Systems. So I think I won't have to explain anything on his behalf. I know he's more than well able to introduce himself. So over to you, Duncan.
Thanks, David. Yeah, so as said there, my name's Duncan. I've just come from finishing up the Emmie Energy Systems from my bedroom. And I can say definitely confidently looking back now, there's absolutely no other postgraduate program in Ireland or abroad that I'm aware of that I would have rather have taken in hindsight. It was really, really good. I did my undergrad in mechanical at UCD before progressing on, and I was kind of I had slight fear of missing out in engineering, and I quite enjoyed some of the electrical stuff and power system stuff that were touched on in the undergrad, and I really liked that in energy systems there was so much choice, so I got to pick and choose and basically design a really nice course for myself as well within the options that were there. And it was really enjoyable to have that interdisciplinary nature of the course. It actually really stood to me then in my internship, which I did with a company called Electroroute. They look at power markets, so it's mostly to do with wind power and so on. But it all really helped coming together there, and I'm still working with that crowd now. Funnily enough, because I'm fresh out, I have to give them a lecture this week on novel technology and solar power to keep them up to scratch with all sorts of new stuff happening in the Irish market. So obviously I'm still working there, so the employment opportunities were really strong for me. I already had an offer from the after the internship, which was really, really useful. Like it was really nice to break up the program with the internship then, because it really helped with my thesis afterwards. Like I developed such a strong foundation what I was doing. I did a similar industrial thesis, and that was really instrumental. And obviously, right now with things how they are, it was really nice to secure employment from my internship. But even then, I have lots of friends from the course now who have secured employments like since lockdown and with people other than their internship partners as well. So the prospects were really, really strong coming out of this course, I found. And yeah, overall, really, really, really positive experience. Can't recommend it enough.
Very good. Thank you very much indeed, Duncan. I'm as I'm sure it's difficult to make a solo speech and think of everything, so it's always helpful if there are questions and feedback. So Katie, do you want to just take over the moderation?
Yeah, we've had a number of questions come through to us, so I would also encourage people to pop them through the Q&A as well. So specifically, I suppose it's just based on the fact that both Duncan and Katherine mentioned that they did an industrial thesis. Just a couple of questions. A, was it hard to get support from your, I suppose, employer at the time through the internship? And B, was it difficult to get approval from UCD to do an industrial thesis? So maybe we'll go to Duncan first on that.
Sure. Actually, I mean, I suppose there's maybe a perception sometimes that if you're an intern, you're not always overly useful. But it was really easy to secure permission and support for the industrial thesis from the crowd I was working with, because they felt they had really benefited from having me and other UCD interns there. I have friends who did the same in the same course and same employment partners. So they were really willing to work on that and really eager for that in actual fact. And on the UCD end, again, couldn't have been easier. Like it was just a case of talking and identifying a supervisor and ironing out a couple of details, and then it was a really, really nice dynamic. I'd recommend it.
And Katherine?
Yeah, I had quite a similar experience. Stryker were actually really eager for me to do a project and kind of offered me a few kind of different topics so that I could go around and I think about what exactly I wanted to look at. So certainly it was really positive from that side. It wasn't difficult to get them to work with me. On the UCD side, Ken Stanton was my supervisor and he was brilliant. So I think it's really about finding a supervisor who has an interest in the area that your company does. So I think that worked really well, given that Ken would have a lot of experience with biomaterials as well. So I did not find it difficult to kind of organize. And I also would agree that the support is great between the two. So I would have kind of regular meetings with Ken, do my own work, and then have meetings every 2 weeks with the team in Striker as well, which is brilliant. So I got a lot of feedback and a lot of help throughout. So yeah, would recommend, definitely.
Thank you for that. I suppose just staying on this kind of a similar topic, someone's just asking, you both obviously did programs that had internships embedded into them. How easy was it to secure your internship? How did you go about it? I suppose a little bit, what was your experience of the process in doing that? Katherine first.
Yeah, great. So essentially it's kind of run through UCD, but you can also go out and approach companies yourself. So it's a pretty busy time, I will say that. You know, you're putting together CVs and cover letters for a lot of different companies, and you're doing a lot of interviews around midterm time. So it's busy, but I didn't have any issue getting a placement. I actually got a few offers, which was brilliant. And I think my classmates were the same. I don't remember anyone not succeeding in getting a placement. I think everyone managed to get one and enjoyed it. So I wouldn't be worried about that, certainly. I don't know, Duncan, if your experience is any different. But...
No, my experience was very similar. Again, it was busy and a bit of a mad rush running around preparing for an interview and throwing a CV together. But it was ultimately very straightforward. And I think internally in UCD, the process is very streamlined. So that really helped. I do remember kind of everyone was quite anxious in the build up to it because different companies operate at different paces. But then looking back, certainly for all of my friends, things worked out really well. Everyone got an internship they really enjoyed. So no, it was very well streamlined.
Thank you. I think it's also just worth mentioning the college itself has 2 internship managers that are there to build up the relationships with the companies who take our students. We also have a careers support centre, and we have a dedicated person just for our college itself. So there are other supports available in terms of the CV writing skills and maybe mock interviews that are also organised through the college. So students can engage with that as much as they feel that they required in order to prepare themselves. David, a question for you, I think, in relation to being Programme Director of Energy Systems. Someone asking, is it possible to do Emmie Energy in less than 2 years?
In less than 2 years, yes.
Yeah.
For candidates who have already completed, say, a 4-year degree, it is possible, and possibly some candidates have already got some industrial experience or a significant placement, that we can shrink the course to 12 months by awarding them effectively 30 credits for their prior learning, which means that they do a slightly more intensive version of the course, 6 modules in trimester 1, 6 modules in trimester 2, and a research project over the summer. So in fact, over the years, quite a significant number of students have completed the program on that basis. These are students who typically graduated in other countries or in other Irish institutions. Just make one point following on the previous discussion that the students who have gone out on internships for us have represented us extremely well and cleared the pathway for the next year's students, and we have employers very, very keen to get in quickly, and that's partly explains the scramble. There's also another aspect of this that really suits the university, that it opens out channels of interaction between university and Irish industry that weren't really possible before. And so a company that has, a smallish company perhaps, that has limited experience of research projects can get one started with through an internship and the subsequent research project with very little cost and bureaucracy, and I think this is it's helping to develop the wider industrial base in Ireland. That's a separate point. Thanks, Katie.
Yeah, I think that's a good point, David. Two questions for you, Mert, in relation to the materials side. The first being someone asking, is it possible to do the, I think it's the ME as a part-time? And then the second part of that question coming through is, what's the major difference between the ME in materials engineering program, which is a 2-year, and the MNGSC in materials engineering, which is a 1-year?
Yeah, the first questions, like unfortunately, we don't have the part-time option for that program, but we have a 1-year option, as you just mentioned. That's the main difference between the ME materials program and the MSNG program. So the main difference between the ME materials program and the 1-year MSNG program is that the 1-year program is not accredited, and it doesn't involve professional work experience. So, but you still have the project during the summertime. So you will be graded in you have to write a thesis during the summertime, but those are the main differences. So one is a 1-year program, doesn't involve the professional work experience, which is 6 to 8 months. And also the 1-year program doesn't have the accreditation. So I would recommend the 2-year program, of course, because of the professional work experience really gives the students the ability to see the industrial environment and the experience, so that when they finish the internship, it is easier for them to find, to secure employment. But of course, there is the 1-year option. So.
Thanks for that. And actually, just while we have you there, Mert, someone asking, what other backgrounds do you take onto your program beyond engineering?
So normally, like other than the engineering, we look at the candidate's background, if it is based on the chemistry or the relevant backgrounds in the other fields. But the core, as long as the core knowledge is there on the fields, like science fields and math, physics in there, and if we see like it is feasible that you can actually follow the ME materials program, we accept that. So basically, science, chemistry are all relevant programs for the ME materials science, other than the field.
So I think what we're saying is, even if they're not from an engineering background, but they think that they've got the prior learning, it is worth making the application.
Exactly, yeah.
Yeah.
Katie, I might explain that for energy systems, a similar thing applies. We have had a number of graduates, perhaps from a physics area or something, but because the engineering programs, master's programs are professionally accredited, there's quite a significant list of professional engineering outcomes to do with finance and management and ethics and so on that we have to include. So in that instance, we have taken people with, say, a physics degree and put them, designed a bespoke version of a 2-year program for them, but typically it may be difficult to fit in the long work placement depending on their background. But we would also include modules in engineering design and manufacturing, and really trying to bridge the gap between science and engineering. But we have been able to facilitate a relatively small number of students over the years, but with bespoke courses.
Okay, thank you for clarifying that, David. And we just have a final question, and David, you might be interested in answering this. Someone noting that the college, and I suppose the school, is a research intensive school, and how does that benefit the students through teachings?
Well, I suppose the first point is that as we move from what the norm being a Bachelor of Engineering program in the past to the master's level, the ME level, the main significant difference between them is an expansion of the depth of research skills, and the students do a more advanced research-based project. And this, of course, ties in with the very large number of PhD and postdoctoral research projects that we have that are active in the college, that are often funded by European Union or by Science Foundation Ireland. So in other words, the ME students become integrated in many cases in the ongoing research projects that the academic staff are pursuing, and that the PhD and postdoctoral candidates are working on. So there's a kind of a focus on research, and as I mentioned earlier, as all industries, especially in this country, have to compete internationally into the future. You know, to add to their state of knowledge, to research, to innovate is essential. And so we're also trying to be part of that ecosystem, as it's sometimes called.
Okay, thank you, David. And I think that concludes our questions for the day. If anyone has any queries or requires any follow-up, you can email me. I'm katie.o'neill@ucd.ie, and that's katie.o'neill@ucd.ie. So all that's left is for me to sincerely thank our academics, David Timoney and Mert Celikin, for their time, and also for our two very recent graduates, both Duncan and Katherine, and I wish you all well and thank you for your time today. Take care.